Thank you very much. I'm very excited to talk about hardware security modules here. It's a conference that I've been very excited about. So just really quickly, to go over what is a hardware security module. It's basically a physically secure device designed for key management and processing operations involving those keys. There's a few different kinds of them. The traditional kind is a server where it's either directly connected to the server or networked. There's also the idea of a client-side secure element, such as the secure element in your iPhones or in various higher-end Android devices. There's the idea of a virtualized HSM on a cloud deployment like Amazon Cloud HSM or Azure Key Vault or other clouds, as well as there's processor and platform technologies such as Intel SGX and ARM Trust Zone that implement a lot of the same functionality as HSMs. We're primarily going to be talking about the hardware security modules on servers, but it definitely touches on all of these. So there's three main points that I'm trying to convey. First is that HSMs are critical system components in the systems where they're used, but they're also kind of hard to inspect, use, and trust for a variety of reasons. Second, they're becoming more important again. They were sort of like, they were always important, but there was a period of time where they were pretty much, the industry wasn't changing very much, and that's changed very recently. And there's some new uses for HSMs that are actually really exciting new uses of these devices, but they have different requirements than the older uses. So there's sort of a conflict in the industry right now between the older solutions and the newer solutions. So there's some important concepts, just really briefly. The idea is that the HSM protects a very small portion of its functionality inside a secure envelope, protected by hardware, software, firmware, everything else. And this is the trusted computing base. It's designed just to do the operations on the key. It's not the overall application. It's just a very small subset of the application. The HSM has a bootloading process where you load custom code into it, where you load the normal applications. It's sort of like a small computer that's inside your computer. And one of the key elements of the HSM world is remote attestation, where you can prove to someone not directly connected to the HSM that this is a valid device that has integrity and is going to operate the way it's supposed to operate, that the keys are managed under certain rules. Because of how these are deployed, there's a concept of the keys aren't just owned by one person. It's not your large bank that's deploying these doesn't have one person that owns all their keys. They have the concept of an administrator of the system as well as somebody who owns an application's key. So there's a lot of process and things built around how keys are managed within the application. And because these keys are so valuable, they don't just sort of get created and then thrown away. There's a whole lifecycle management of these where they're rotated, managed, everything else. And because the buyers are large organizations, governments, banks, everyone else, they really care about certification. And certification is actually a very important point that we're going to discuss a little bit later. So yeah, as I said, they're critical system components, but they're hard to inspect, use, and trust, which you would think doesn't really make sense because you're putting so much highly trusted stuff in them. How does this make sense? So in one way, they're hard to use because they're a physical device, and a lot of applications are moving into the cloud, and this is one of the things that makes it hard to move your existing application to the cloud. If you make extensive use of the HSM, you're going to have to move it to the cloud in a different way than you would move the rest of your application. You can't just sort of naively virtualize it. They're black boxes. It's sort of, part of it is inherent to how they're built. They're designed to be tamper responding, tamper detecting, everything else, so it's hard to inspect them. But it's also just the fact that they are tricky to work with, and they work in weird ways, and they're not normal system components, so people don't have a lot of familiarity with them. So from the perspective of an administrator, I've come to deployments where I'm not familiar with a particular brand of HSM, and to me, it's a weird component that's also system critical for reliability, security, everything else. So I have to learn about it, and I certainly don't know as much about every brand of HSM as I do about commodity components like x86 servers or virtualization. So that's the tricky part of it. And unfortunately, these devices, in a lot of cases, have a really long product life cycle, and a lot of the tools are pretty outdated. They were designed for older versions of operating systems. They were designed around different deployment models. They're not really up to date with everything. The buyers are conservative, the vendors are conservative, so you end up with just sort of, it's just sort of wonky in a lot of ways, which is kind of annoying if it's something that you're depending on for security. And there's an inherent problem that these devices are designed to fail securely in a way that erases the key or prevents external access to the keys. But at the same time, they're holding your most critical things, and they're often in the critical path for your application. So if they detect a tamper event, you've got a problem. There's actually an interesting story about this where one of the most secure HSMs that was ever made by IBM in the 1990s, they were a little bit late on their shipping schedule, so they decided they're going to air freight all of them to hit the deadline or whatever that they're trying to hit. And they put them on commercial aircraft as cargo on the plane. And they have temperature sensors in them as part of the tamper-responding technology. And every one of them that arrived, as far as I'm aware, was bad because it had hit a negative 40 C in the cargo hold of the aircraft. So there's sort of a tricky thing there. Also, they're really expensive. HSMs are basically, for real production ones, are in the tens of thousands of dollars, and your deployments are in the hundreds of thousands of dollars. They have a lot of complexity. I had an application where I had to roll out something in about 3 weeks, 4 weeks, which is definitely short, but just negotiating with vendors to be able to buy them was such a pain that we ended up actually working around the solution. And the long sales cycle, they're not commodity components in any sense of the word. And the real problem I have with HSMs is that in a lot of cases they're being used in a way that really doesn't exploit 95% of their capabilities. They're just used to sign something using usually PKCS11 or whatever to manage the keys and sign something. And there's an obvious problem with that of if you compromise the host that it's attached to or the system it's attached to, you can just submit a new request to it and say, sign this thing, and it's as if the key was on there. You do have the ability to revoke the key and everything else, but if it's something like a cryptocurrency application where signing the transaction is the goal of the attacker, then it doesn't matter if you still have the keys after you've signed the transaction. So they're used in a sort of limited way. They're sort of like zombie devices. So also, HSMs are all these factors do exist, but I do believe HSMs are becoming more important again. I've seen the market is $20–30 billion market if you include client-side devices already. So it's a big market, but it was sort of this sort of like niche market that you didn't really care too much about outside of the client side, but that is definitely changing. Just really quick, they've gone from the size of like they had a mini computer inside a safe. The early ones. They're used for banking and infrastructure. I think DNSSEC is one of the largest deployments, as well as the X509 CA infrastructure, where they're required to use the CAs. But there's a lot of banking applications, PIN processing, things like that, where they're pretty widely deployed. The weird thing about the industry is consolidation has been really massive. I think there are 2 big companies now that are responsible for most of the market after they acquired a lot of the other ones, and there's probably a long tail of 20 or 30 others that are used in certain countries or in certain applications, but they're not anywhere near as big. And the cost has actually gone up. Instead of things like, I remember when I could buy an HSM, like when I was shortly out of college, I was able to save up a lot of money and buy like a $3,000 HSM. You can't really do that for production HSM today. They're going to be $20,000, $30,000. So it's kind of contrary to what you would expect from technology. So yeah, all these things. And the product cycles have gotten longer. Vendor consolidation has a lot of, it just lowers innovation and everything else. And the other factor is that you don't really need an HSM for a lot of the things that you initially needed the HSM for in the 90s. So some of the older applications don't require HSMs today. It used to be that the CPU was not fast enough to do public key crypto or other cryptographic operations. So you ended up using them as hardware accelerators. And that was sort of the biggest part of the market. HSMs were the high end of that market, and there's a little bit of crossover between the two. But now on your smartphone or on embedded devices, you have super fast performance in most cryptographic operations now. So you don't really need them as cryptographic accelerators so much as you do for the security functionality. So that made the market smaller and raised the cost. And they're a pain to work with, even when they do work in the cloud, they're a pain to work with because they're managed using different tools. So you can't, I had a large AWS deployment where we were using stuff, and we have a great AWS guy. But managing the HSMs involved a weekend of sitting in a room with a bunch of other people on camera, like copying stuff off of a screen and doing everything else like that. So and everything else was deployable with one click out of CloudFormation. So there's some rough points there. So you'd think this is like a declining market, but it's not actually. There's these factors that make it cool. I realize that the crypto is not cryptocurrency, but cryptocurrency is a big application for these now, and it's cool because it spills over into other applications. Cryptocurrency people do actually care about protecting their keys from insider attacks and things like that in a way that most other applications outside of CAs and some other things didn't care about as much because it's directly monetizable when it's attacked. And they do have the resources, or at least they did have the resources until a couple months ago to protect against these things. Key management in general and authentication are important tasks, and they're great things to manage here. And as applications get more, they have a better security model, you can actually identify the small part of your application that needs this extreme level of protection and place that inside the security barrier of the HSM. If you've just got a new application where you don't really, where you can't identify that piece of it, or if you're not able to do that, then you don't really gain anything. But with this, with some of the more mature applications, you can actually identify which pieces are security critical and place them inside a security envelope. And thanks to the cloud vendors, the deployment models and tools for HSMs have gotten dramatically better in the last probably 2 years. It used to be this long sales cycle of buy HSMs up front and do everything else, but now you can actually just go to AWS, Azure, Google, and I think a couple of other cloud vendors and pay a relatively small amount of money to have some HSM functionality. The tools are not as good as the other tools on the same platforms, but they are certainly better than the standalone HSM world was before. So this is all kind of painful and like, why would you bother with it? But the HSM actually is a solution to a lot of problems that are even bigger problems than the HSM's own problems. So key management for super high value keys. There are keys that are protecting hundreds of millions of dollars, billions of dollars in assets, and there's a lot of principles you want to apply when you're managing a key like that. You want to have separation of roles, internal control. You want to make sure that no single person has access to that key, that the key's lifecycle is managed, and there's reasons why you want to protect the keys from single person having control of it for a variety of reasons. You don't want a person to be a kidnapping risk. If you have one person inside your organization who controls a key with $1 billion behind it that can access it at any time, at any location, that person has a very, very bad life and possibly a lot of security problems. So HSMs are a great tool to work around that kind of thing. This is the basic description of the cloud. You're trusting some physically remote hardware somewhere in the world that you've never seen before with your most critical secrets. So doing that on commodity platforms, you can build a lot of process around that. You can build a lot of, hey, I trust this large Fortune 20 company with a lot of my secrets and everything else, but it's much better to use hardware to trust. It makes the ecosystem much more vibrant and makes it easier to enter, and it's just safer, and HSMs are a solution there. Third-party application updates, another problem, like you've got this application that's running that has a lot of your data in it. Are you just going to run the newest version of the application? Are you going to audit the entire application each time? HSMs are cool because you can place the security critical part of your application inside a different environment, update the rest of your application, and know that certain security promises are going to be upheld by the HSM. So it lets you stay up to date on your applications, which is good from a security perspective as well. And also very important, it lets you limit the impact of bugs and breaches. I mean, I don't know, probably bugs are a bigger issue than breaches in a lot of environments, but if you use the HSM to protect your key secrets, or your keys and your secrets, then a bug in another part of your application can't break the HSM, so the HSM will protect you from some of those parts of the application. This is not really news to anybody in the non-internet world, like people in finance, people in the various infrastructure world have been using HSMs. They're required by Web Trust and SOC 2 for CAs and everything else. So there's a lot of applications that have used them successfully for a period of time, but they're just not the first choice if you're building a completely de novo application on the internet because of the complexity to date. And they really are like already dominating the world because of devices like the iPhone and Android devices and everything else that have secure elements in them, and they process keys and manage stuff on local devices. So this is really a case of the client sort of leading the server side. The server side has been a little bit lagging behind it. So, but why haven't they taken over the entire world, including the server side of the world? Again, there's new uses and they have different requirements, and the HSMs that exist today are designed for a world that isn't necessarily what the new applications are going to be. Tools are still pretty painful. They're not designed for orchestration. They're not designed for any sort of automation. They're generally designed for single system deployments. There's some cases where they've got some other manageability, but they're not as good as other tools, which is unfortunate. And the cloud-based HSMs are great, but they're pretty new. The cloud-based HSM until about 2 years ago consisted of like one employee at Amazon who would go and buy HSMs and place them into the rack and sort of give you access to it. So it was basically a remote HSM, but it was a sort of a managed by Amazon through their portal. But it was basically just a regular HSM remotely. So and they're sort of evolving over time. So there's that. And the thing that makes HSMs really awesome that no one exploits to the capability, to the degree that they should, is being able to put custom code inside the secure envelope of the application. And doing that is still a pain. Like, it's not gotten any easier. It was actually easier in like '99 to do this on NCiphers than it is today on any of the platforms I've found. So there's a variety of reasons for that, but it's a pain. And that's something that needs to be improved to make stuff work. There's the cool things, Intel SGX and TrustZone, that are sort of included free with your processor, and they're great, but they have some limitations. They have development and deployment limitations. The SGX rollout was like just later this year for like 5 years, and the issue of how you can get approved to be in the developer program and how you can be able to publish applications has still been sort of a sticking point for people for a while, and it's not as secure as the conventional HSM in certain deployment models. So there's some issues there. And the thing that is the saddest is the certification process itself. It's great that they're certified. They're certified by NIST and the Canadian Communication Security Establishment in the US and Canada. The certification process, there's been some debates over like, there should be a FIPS 143 version of this from like 2004, there was a debate about that, but it hasn't really been decided yet. The certification process is a mess. And the primary reason it's a mess is that it makes any change to your product, including adding new support, anything else, take a 6-month recertification. And as a result, products like Amazon Cloud HSM for a long period of time did not support a lot of the curves that people wanted for things like Bitcoin or whatever else. You were stuck using just the NIST curves, like the P256 curves. So the certification process itself adds a lot of limitations and delay to the process, as well as expense. So the easiest path forward to doing this stuff is to use less expensive non-FIPS or maybe FIPS optional HSMs. There's Yubico, the guys who make the end-user authentication devices make a UB HSM. They make a new version of it. It's about $600, and it does a lot of what you want from an HSM if you're just using it as a signing device. And it's easy to buy. You can buy it on their website with a credit card. It's pretty awesome. There's some other devices that use, like the USB Armory out of Italy, that is really amazing. It does a lot of what you want for modern applications, and it's cheap. It's like under $100. Simplified development would be nice to have, but yeah. So the clouds have been integrating some functionality. So you can use the HSM on Amazon and Azure and to some extent Google with just using it as an HSM to manage certain keys, but you can also, it's built into the back end of some of their other applications, like AWS KMS lets you do HSM-backed keys, so they're building it in the back end, so you don't even need to know that there's an HSM involved, and you get a lot of the functionality. And unfortunately, they're all operating in FIPS mode, so you're limited by which algorithms are available. It would be really nice to have the expansion to make it easier to develop code for these devices to run on the device itself, where you can use either SGX with remote attestation, or where you can use the HSM code environment. This would be something, it seems like it would be a fairly trivial change to have, just sort of process change over time. And the greatest area that's been working pretty well has been people deploying multiple technologies together. There's the like Intel SGX and an HSM. You can get the best of both. You can be able to build an application in SGX, which is also available in some of the cloud environments, to build your own custom application logic, and then still keep the HSM for managing your keys. So there's some cool trade-offs there. Maybe there'll be a new certification standard someday. I'm not really holding my breath. And that's sort of the default path. Those are all fairly realistic things that are going to happen. But I think there's some stuff that could happen that isn't as obvious, but could be pretty awesome. There's a gap between sort of the regular HSMs and the path they're going to take and the platform security stuff. And what I would love to have would be an HSM that's actually open. Rather than having it come from a single vendor, I would like to be able to basically have a hardware spec, software spec, buy it from multiple vendors, know that there's no permission required to build applications for it, and have these devices designed so that the end user or the end user's organization can actually audit it and inspect it. And have a whole range of price performance from like $50 up to $20,000 and have a full range for these new applications. It's mostly a software problem. It's not really a hardware problem. We have software, we have hardware systems out there that can support this, like things like USB Armory, various embedded platforms that can do all this stuff. They just need to have a tool chain and firmware and deployment model for it. But unfortunately, it realistically has to be something that's supported by cloud vendors to be popular going forward, and getting cloud vendors to support any new hardware is going to be a huge pain. So it's probably something that maybe some of the smaller clouds or maybe experimental products will use. It's definitely not the high-end option because you're going to want the certification for the high-end vendors, but it's something where there could be some innovation, and there's some pricing pressure from the low end from platform security. But if it's open source, if it's free and open, I don't think it's a serious problem to have options. So it seems like the solution that would be ideal for going forward, and I'd like to see this happen. Cool. So with that, I'd like to open any questions and discussion. Thank you.